Astronomers have spotted a galaxy so far away that it raises troubling questions. This discovery isn't just another distant flicker of light. It's a cosmic signal that threatens to unravel our understanding of the universe's earliest moments. To grasp why this matters, let's journey back not to the beginning of time, but to the tools and ideas that have shaped our view of the cosmos and the delicate threads of theory now trembling under the weight of this new find. For decades, telescopes have pierced the veil of space, each one pushing deeper into the past. The Hubble Space Telescope, with its modest 2.4-meter mirror, once held the crown for spotting the farthest galaxies, revealing ancient systems like GNZ11 glowing faintly at the edge of our vision. But Hubble's reach had limits, bound by the visible and ultraviolet light it could capture. Then came the James Webb Space Telescope, a marvel of engineering with a 6.5-meter golden mirror designed to drink in the infrared, the stretched ancient light of the universe's infancy. Webb didn't just extend Hubble's gaze, it shattered its boundaries, unveiling galaxies so old they shouldn't exist by our current models. Among them, a new discovery has emerged, a galaxy so distant it defies expectation, with a redshift of 15.1, placing it a mere 280 million years after the Big Bang. Redshift, in its essence, is the universe's way of telling us how far and how fast something is receding. The higher the redshift, the older and more distant the object, its light stretched by the relentless expansion of space. This galaxy, tiny at just 400 light-years across, barely a speck compared to the Milky Way's sprawling 100,000 light-year disk, should be a faint whisper from the dawn of time. Yet it blazes with a ferocity that stuns astronomers. Its brightness suggests a frenzy of star formation, a cosmic forge churning out stars at a rate that defies the sluggish, tentative growth we expect from the early universe. A galaxy this young shouldn't have the strength to shine so fiercely, nor the chemical complexity to suggest multiple generations of stars have already lived and died within it. What makes this discovery even more unsettling is its structure. Most galaxies, even in their youth, show signs of a central supermassive black hole, a gravitational anchor that shapes their evolution, regulates star birth, and fuels dazzling quasars. But this galaxy lacks any trace of such a beast. Its light, dissected by Webb's spectrograph, reveals a chemical portrait rich in oxygen and carbon, elements forged in the hearts of stars that must have exploded as supernovae long before this galaxy's light began its journey to us. This suggests a universe already bustling with activity, far earlier than our models allow. The absence of a black hole, combined with this chemical maturity, paints a picture of a galaxy that shouldn't exist, a cosmic anomaly that forces us to question the rules we thought governed the universe's first chapters. The implications ripple outward, touching the foundations of cosmology. Our models of galaxy formation predict that the early universe was a sparse, slow-burning place, where small, dim galaxies gradually coalesced from clouds of hydrogen and helium. These first systems were expected to be chemically pristine, with heavy elements like oxygen or carbon appearing only after eons of stellar life and death. Yet this galaxy, and others like it uncovered by Webb, are neither dim nor simple. They're vibrant, complex, and inexplicably mature, as if the universe hit the ground running, assembling intricate systems almost as soon as light began to shine. These findings hint at a cosmos far more dynamic than we imagined, where galaxies formed faster, Stars burned hotter, and the seeds of complexity sprouted before the universe had time to settle. But the questions don't end with galaxy formation. This discovery nudges us toward a deeper, more troubling mystery: the nature of the universe itself. Some theorists grappling with these anomalies have begun to explore radical ideas. One such notion posits that the universe's accelerated early growth might be tied to an unseen force, not dark energy or dark matter, but something entirely new: a scalar field permeating space, driving rapid structure formation in the cosmic dawn. This hypothetical field, dubbed early dark energy by some, could have briefly dominated the universe's infancy, speeding up the collapse of matter into galaxies before fading away. If true, it would mean our understanding of cosmic expansion and the forces shaping it is missing a critical piece. Yet, there's an even bolder hypothesis, one that stretches the boundaries of imagination. What if the universe's strange behavior, its precocious galaxies, its chemical richness, its defiance of our timelines, points to a deeper truth about its origin? Some physicists propose that our universe might not be a singular event, born from a primordial singularity, but a fragment of a larger reality. In this view, the Big Bang was not the beginning, but a transition, perhaps the collapse of a prior universe into a black hole, spawning ours within its event horizon. Inside a black hole, time and space twist in ways we barely comprehend, and the rapid formation of galaxies like this one could reflect the extreme physics of such a realm. If our universe is nested within a black hole, every black hole in our cosmos might cradle its own universe, a cascade of realities stretching beyond our grasp. This idea, known as black hole cosmology, offers a dizzying perspective. Black holes, often seen as cosmic endpoints, could instead be gateways to new beginnings. The Big Bang, in this framework, becomes a big bounce, where a collapsing universe rebounds into a new one, carrying echoes of its past. The chemical complexity of this distant galaxy might then be a relic of that prior cosmos, a faint whisper of a universe that existed before ours. Such a theory could also explain why the universe seems fine-tuned for life. Only black holes that spawn stable, life-friendly universes might persist, a kind of cosmic natural selection. The rapid star formation, the absence of a black hole, the unexpected brightness, all could be signatures of a universe born from the ashes of another. But these ideas, while tantalizing, are not without rivals. Another possibility looms, one grounded in the physics we know, but stretched to its limits. The early universe might have been seeded with primordial black holes, tiny but numerous, formed in the chaotic aftermath of the Big Bang. These miniature black holes, unlike their supermassive cousins, could have evaporated quickly, releasing bursts of energy and matter that catalyzed galaxy formation. If these primordial black holes were more common than we thought, they might explain the rapid assembly of galaxies like this one, injecting the early universe with the raw material needed to forge stars and heavy elements. Yet even this explanation struggles to account for the galaxy's brightness and structure, leaving astronomers searching for answers. The discovery also raises questions about the universe's large-scale structure. Recent studies hint at a subtle asymmetry in the cosmos, a faint alignment in how galaxies spin and cluster. This cosmic anisotropy challenges the cosmological principle, the assumption that the universe looks the same in every direction on vast scales. If this distant galaxy, and others like it, formed under the influence of a preferred cosmic axis, it could suggest that the universe's early conditions were not as uniform as we thought. Perhaps the rapid formation of these galaxies was shaped by a primordial ripple in space-time, a relic of the Big Bang, or even a prior universe. Such a finding would force us to rethink the very fabric of reality, from the smallest particles to the grandest structures. As we grapple with these mysteries, the tools of discovery are evolving. The James Webb Space Telescope, for all its power, is just the beginning. Soon, the Nancy Grace Roman Space Telescope will join the hunt, its wide-field surveys capable of mapping thousands of ancient galaxies. Together, these observatories could reveal whether this galaxy is a cosmic outlier or part of a vast population of precocious systems. Each new discovery will chip away at our assumptions, forcing us to confront the possibility that the universe is stranger, more interconnected, and more dynamic than we ever dared to imagine. The Vera Rubin Observatory, set to scan the southern skies, will add another layer, tracing the distribution of galaxies across time and space, searching for clues to the forces that shape them. Yet for now, this galaxy stands alone, a beacon from a time when the universe was raw and unformed. Its light, traveling for 13.5 billion years, carries questions that pierce the heart of cosmology. Why is it so bright? How did it form so quickly? What does its chemical richness tell us about the universe's first stars? And most troubling of all, does it hint at a reality beyond our own? A cosmos nested within a larger tapestry of existence? These questions are not just scientific, they're philosophical, touching on our place in the grand scheme of things. If the universe is a black hole, or a fragment of a prior reality, what does that mean for us? Fleeting sparks of consciousness on a tiny planet? The answers, if they come, will not arrive easily. Each new observation, each spectrum of ancient light, brings us closer to the truth, but also deepens the mystery. The universe, it seems, delights in defying our expectations, revealing itself in glimpses that are both breathtaking and humbling. This galaxy, with its impossible brightness and enigmatic structure, is a reminder that we are still beginners in the cosmic story, piecing together a puzzle with no edge and no center. Its discovery is not an endpoint, but a challenge, an invitation to look deeper, think bolder, and embrace the unknown. In the years ahead, as telescopes grow sharper and theories grow wilder, we may find that this galaxy is just one of many, a single note in a symphony of cosmic creation. Or it may remain unique, a solitary enigma that holds the key to the universe's deepest secrets. Either way, its light has already changed us, stirring a sense of wonder and unease that drives us to explore. The universe is not a static backdrop, but a living, evolving mystery. And this galaxy is its latest revelation, a troubling, beautiful question mark etched across the sky. What lies beyond this discovery? Perhaps a new physics, a new story of creation, or a glimpse into realities we cannot yet fathom. The universe has always been a place of surprises, and this galaxy is no exception. Its light, born in the crucible of the cosmic dawn, carries a message. There is more to the story than we know, and the next chapter is waiting to be written. As we peer into the abyss of time, one thing is clear. The cosmos is far stranger and far more wondrous than we ever dared to dream.